For this postfix assignment, we are given the following things or rules that we have to follow when we are doing this assignment, and we're going to have to take that account when we're actually coding for this assignment. This code right here is not part of the assignment. We're going to have to make a new Java project to do this assignment. So I'm going to go in here, click New, click Java Project, put my project name in here, click Finish, don't create, and then we are going to open and go into our SRC, right click, New Package. We'll make our package main, click Finish. We're going to go inside of our package, New Class. The class in here we're just going to call our driver class. We are going to have our public static void main string args selected so we don't have to fill it out, and then click Finish. And this is our code so far. We are going to have to write all of this and go through the assignment. Very simply, this is the assignment rules. We have to grab an expression from a user and evaluate it, and it's going to be infixToPostfix, and then we're going to have to code from that. We're going to use stacks, queues, and list nodes. However, what we are not going to do is use the predefined stacks and queues. We're going to have to make our own stack and queue class. First, we're going to start with our main class. So in our main class, we are going to have to prompt the user. We have give me an expression. So inside of here, we're going to have a sysout statement. We're going to have give me an expression, and I'm going to change this from print line to just print. That way, expression whenever the user puts it in is going to be on the same line. Since we are taking user input, we are going to need a scanner. So we're going to use scanner. We're going to call it input and set it equal to a new scanner. And then inside of our parentheses, we have system.in, and that will give us the user input. We are allowed to import the scanner class, so we're going to do that, and it appears up here. So now we just need to take the user input and store it in a string. We are going to do string, we're going to call it expression, and we're setting equal to our input dot next line. That way it'll give us the next line of user input. It will give us the total input. And our output should look like this. So we're going to take this entire line and store it into our expression. Now we want to convert this to postfix. So what we're going to do is push this expression as a parameter to our method. And with that method, we are going to change it to the postfix notation, where we have postfix notation, and then we're going to append to this string after we have this done. And after we do this, I'm also going to have an answer section because it wants us to print out the answer. So we need a sysout statement, we need our answer, and then it is going to be like this. So this is our entire main method almost done. To do the postfix notation, we are going to make a postfix class. This is going to be postfix, like this. So what we can do is go below our actual driver class. We're going to do public. Actually, we cannot do public because in one Java document, we can only have one public. So we're just going to do class, and we're going to call it postfix. And this is going to be our class. So in this class postfix, we are going to need a method, and this method is going to change our expression to the postfix notation. So we'll call our method infixToPostfix. So we're going to do postfix dot infix to postfix, and the parameter is going to be this expression. We're passing this through, that way we can analyze it, and in our class we'll then have our method manipulate the expression, so it will change it to the postfix notation. We're going to want to store this inside of a string, so we're going to do string, and then we can call this postfix expression because we've changed the expression to be postfix from infix. We can hover over infixToPostfix and click create method, and this will automatically create a method for us. And this will let us know that we're going to have to write inside of here later. So what we're going to want to do, once we have this written out, once we have our postfix.infixToPostfix expression all figured out, we are going to print it out right here. So that is going to give us our postfix notation. Now for the answer, what we can do is, because we want to have this answer right here, we're going to evaluate our postfix expression and then print out the answer. So we can have a method inside of our postfix class that will evaluate this. So we're going to do postfix again dot, and we'll just call this evaluate because we're going to evaluate our postfix expression, and then we're going to pass through it our postfix expression. That way again we can evaluate it. You can hover over evaluate, click create method, and it creates a method for us. So now we're going to use these two methods along with some helper classes in our class Postfix to actually code for these method calls. If we look at the instructions, it tells us that we need to convert from infix to postfix using a stack and a queue. So inside of our postfix class, we are going to have one stack and one queue. The stack is going to store our operators, and the queue is going to store the operands and whatever we need to pop out and kind of combine. So we're going to have to make our stack and our queue here. We would write them like this. We have a stack. We're going to have a character inside of these two angle brackets. We're calling it stack. We have a new stack because we need to make a class for this. That way we can use this object. And then we're going to have the character inside of these two brackets. The reason why we have these two angle brackets and the actual character, the type in here, we could put integer or string if we wanted to, is because we need to specify the type that is being pushed into our stack and into our queue. We don't necessarily need to all the time, but it is good practice. So you do that for both the stack and the queue. We do have errors here, and that is because it cannot be resolved to a type, meaning that we basically need a class. We haven't created a class for it, but we will after we do this postfix class. So we have created our stack and our queue. Now what we're going to want to do is add to our stack. If we look at how to do infixToPostfix notation, there's a video on that linked in the description, but basically for the code, we are going to have to add to the queue. Like we said, if it's an operator, meaning if it's like a plus, minus, multiplication, or division, we are storing it in the stack. If it's a queue, we're going to store our operands and whatever we need to pop out. And from infixToPostfix, if something is less than or equal to the previous thing on the stack, that is when it gets popped out into our queue. Again, the theory behind this is linked below the like button in the description. So now we're going to want to add to our stack and queue. To do this, I'm going to work in the infixToPostfix because we're passing through this expression, and now we are going to want to analyze our expression. So what we're going to do is have a for loop, and this for loop is going to go through every single character of the expression. And to do this, we could make a scanner, that could work, but we're going to use the .char at. So we're going to have int a is equal to 0, so it starts at 0, and then we're going to run this as long as a is less than our expression dot length, and that gets the length of the string, and then we're going to have a plus plus. Now we are in our for loop, and we can write this code. So at the specific character of our expression, we want to analyze it. We're going to do char c, so we can store the character in a value. So c is going to be the variable that we store the exact character at. And it's going to change as we increment through our expression every time we go through this loop. So char c is equal to expression dot char at. We can see it's the first thing right here. It gives us the description. If we click this, it's going to autofill a, and then we can just close that off. So basically, we're getting the character in our expression at this index. And this index is being incremented every single time we go through this for loop. So we're going to start at index 0, 1, 2, 3, 4, and however long our expression is, we will go through this entire for loop. So now that we have broken up our expression, we can analyze the character. We've analyzed the expression, we got to analyze the exact character now. And we know that dealing with infixToPostfix, we have numbers, which are the operands, we have operators, which are the multiplication, division, plus, minus, and we also have parentheses. And the parentheses mean something. Again, the theory of that is in the description below the like button, but we are going to have to separate these different cases. Since they are cases and we can separate them, we know that they do different things. We can use if-else statements. So if we have a number or if we have an operand, we're going to do if, and then we can do character. And this is the same thing as using the string methods. So if we were to do string dot, or if we were to do integer dot, and we have all these classes here, not methods, classes. So we would have character dot, and we can see we have all of these classes come up. And what we're going to use is the dot, and then we are going to have is, and then digits. If we type in is digit, there's a couple of different things we have here. We have is digit, We have is Java letter or digit. We also have is letter or digit, but all we need here is the is digit. It takes a char as parameter and it's a boolean. And what it basically says is that if the character that we're storing in C is a digit, we are going to be in here. So that means a digit 0 to 9. And we know that the output is going to only be through 0 and 9, between 0 and 9. So we don't have to worry about any of that. So if a character is basically between 0 and 9, we are going to be in here. And remember, if it's a digit, it's an operand. And if it's an operand, we're going to just add it straight to the queue. So we're going to do queue.add, and then we are going to have the character being added, which is our C. We have an error here for the queue. We can see that we have an error for our queue, and this is because we have not yet coded the class. However, we will, and it will fix this. So this is for if we have numbers. The next case is if we have open parentheses. So we're going to do an else if, and then in our else if, we're going to see if our character, so C, is equivalent or equal to the C, or I'm sorry, the open parenthesis. So if our C is this open parenthesis character, we are going to be inside of here. And if it is an open parenthesis, we are going to push it to our stack. So we're going to do stack dot push, and then we're just going to push our C. This is going to give us another error, and that's because we've not yet created the push method in our stack class. We have not even created the stack class yet, but we will do that eventually. So this is for open parentheses, and now we're going to make one for closed parentheses. So we'll have another else if statement. We'll have if our C character is equivalent to the closed parenthesis, we will be inside of here. Now we know once something hits the closed parenthesis, we are going to stop looking at our expression, and we are going to pop everything off of our stack until we hit the open parenthesis. So what we're going to do is use a while loop, because we're going to do this while this is true. We're going to have a while, and we're going to run this as long as our stack is also not empty, because we don't want to run it while our stack is empty, because we might get some kind of error. We'll have while, and then we're going to do stack is empty. And the reason why I'm just coming off with these method names is because if we were to use the stack class, these are the methods that we would use. We just have to code them manually ourselves. So if stack is empty, but we have a not in front, so while stack is not empty is basically what we're saying, we are going to be in this while loop. But we also have another condition. We want to pop until we hit the open parenthesis, because that is what the theory is. So to see what's under us in the stack without removing anything, we know that we have to use stack.peek, and this is our method, and we're going to run this as long as it does not equal our open parenthesis. Once it does equal our open parenthesis, we're going to break out of our loop. We're just going to pop the open parenthesis but not add it to our queue. So we are in our while loop now. We are just going to pop off and add to our queue. So we are going to do queue.add, and this adds to the back of the queue, and then we're just going to do stack.pop. So this will pop off and add to our queue at the same time until we hit this open parenthesis. Once we hit the open parenthesis, what we're going to want to do is just pop but not add the open parenthesis. So we're going to do stack.pop, and that is just out here. So that is the part, our else if statement, if we have our closed parenthesis. Otherwise, we are going to push to the stack. We're always just going to push to the stack. So since this is an always for everything else other than the specific scenarios that we coded out right here, we're just going to have an else statement. We have an else, and we know that if the previous value in our stack is greater than or equal to the current value, we must pop it and add it to our queue. And again, the theory about this, because it is pretty confusing if you do not understand it, is linked below the like button in the description. So we have our statement, we have what we're going to do. We are going to start our loop. We are going to have while again, and we're going to run this again as long as our stack is not empty, because we don't want to run past our stack. So as long as our stack is not empty, we're going to have to somehow see if the previous operator is greater than or equal to our current operator. Well, we can do this by assigning precedence. It tells us that in the 8th part of the instruction. We have 1, 2, 3, 4. However, we are not going to be using the equal sign, just 2, 3, and 4. So we can say 1, 2, and 3. But we've already also taken care of the parentheses, so we don't even need that. So we're just going to have 1 and 2. We're going to have to look at these cases and somehow make a precedence method in our postfix class. So that is how we're going to compare them. We are going to have this and here, and we'll do precedence. And remember, if the thing below our current value is of greater than or equal value, we are going to pop that value. So we're going to say precedence, and then we're going to do stack. We don't want to remove this value yet because we don't know if it's greater than or equal to. We'll do dot peak, and this is going to be a method. And we're saying if this is greater than or equal, we will pop it. So if it's greater than or equal to the precedence of our current character, we will be in this while loop, and we will have to pop that value into the queue. So what we're going to want to do is we have to make a precedence method. We'll come down below our current infixToPostfix method. And before we do that, I'm just going to add a description for our actual infixToPostfix method. That way we know what our parameter is, what we're going to be returning, and what this is actually doing. So below the infixToPostfix method, we are going to be in here. We are going to create a helper for our infixToPostfix method. It's going to be a public. We know that we're returning an integer, we have to, so it's going to be a static int, and we're just calling it precedence. And then we are going to be passing in a character right here, and in this case we pass in the previous value, so precedence, and we're going to do char c. And now we can be inside of our method. Make sure your char is lowercase. So in here we are just going to assign values for these different cases. Well, the easiest way to do this is just use a switch statement. So to use a switch statement in Java, we are going to have switch, and then we're going to have a parameter for our switch. The parameter is going to be this C, because we are going to be analyzing it and seeing what it is. Switch is kind of like an if statement, but a little bit more organized, and it does have its limitations, but also its benefits. So we have switch C, and then we're going to have different cases in our switch. So case 1, remember it's a char, so we're going to have these, is if it's a plus. Well, normally, after we have a case, we're going to have our colon right here, and then we are going to want to have whatever code we need to get done, and then a break. But if we want it to fall through, because if it's a plus or a minus, it's going to be the same thing, we'll just have another case right here. We're going to have our single quotes, and then we're going to have our colon, and then we are just going to return a 1 if this is true. We're going to set 1 to our lowest case. This plus minus, even though it's ordered like this, is actually the lowest case. It's lower than the multiplication and division. So this is going to return 1. If it's a multiplication or division, I'll just copy this. And this return is kind of like a break. It'll break us out of this method since it hits a return, and that's how methods work. We're going to change this to a multiplication, and we're going to change this to a division, and then we're just going to return a 2. Now, since we do need to return something, if it does not fall into the switch statement or any of these cases for any reason, we're going to have to return a -1. And that just means that it is not there. But this likely will not happen because it has to be one of these if it is an operand. So otherwise, we will again just return -1. So now that our helper method has been established, we can write a description for it. And this is the description for our method. Now we can go back to our infixToPostfix method right here. We have while our stack is not empty and our previous precedence is greater than or equal our current precedence of the character, we are just going to pop from our stack to our queue. So we're going to do the same thing as we did up here, queue.add, and then pass through stack.pop. And that is going to pop from the stack to the queue, so it will no longer be in the stack, and it's going to be added to the queue. I also realized I made a slight mistake. I accidentally created the stack and queue value out here when they should be in our actual method, because they can't be accessed outside of the method like that. So I'm going to paste these in here. I'm gonna get rid of that bracket that just came there, and then I'm going to move these over, and this is where they should be residing. So that is the only issue that I had. Move it from the actual postfix class to inside of our infixToPostfix method. Now that that's in there, we can keep writing. So we are in our else statement once again, and if our operand, the precedence, is not greater than the previous one, so if we were to look at our stack, and we were to say, well, so if we look back in our stack.peek, and if we were passed in a plus or minus for the previous one, this one right here, we would return a 1. And then if we were passed in a multiplication or division right here, well, we would return a 2. If this isn't true, what are we going to do? Well, we can, instead of adding it to our queue, because what we would need to do instead is add it to our stack, we can create a little bit of code right here. If it's not greater than or equal to our current value, we are just going to push it to our stack. So we'll do stack.push, and then we're pushing the character in. And that is going to close off our else statement, and we are next going to just close off our for loop. So that is it for the for loop. And this is all the code that we are going to have inside of this for loop. That is the for loop for infixToPostfix notation with all of the correct comments that's describing our code. Just because we run through the entire expression doesn't mean everything's in the correct place. We've added everything we could to our queue. We're at the end of our expression, but there could be some things left in the stack. That's kind of how the theory works. And if there are some things left in the stack, what we're going to need to do is use a while loop to pop off everything, no matter what it is, and just add it into our queue. For this, we're going to use a while loop, and we're going to say while our stack is not empty. So we'll call the stack.isEmpty method, and then we're just going to have a exclamation mark in front, meaning the not operator. While stack is not empty, we want it to be empty. We're just going to do queue.add, and then we're going to do stack.pop, and that will run us through the entire stack until it's empty. Once it's empty, we're just going to return the queue. So we want to return a string. We're going to remove everything from our queue, put it in a string, and then return the string. So to make the string, I'm just going to call it string ret for return and set it equal to basically empty right now. And then we're going to use a while loop, and we're going to do while queue dot, and we're going to do is empty again, and have the not in front of it. While queue is not empty, we're going to do ret plus equals, and what this is going to do is just going to keep adding on to our ret while our queue is not empty. And then we're just going to do queue dot remove, and that is going to remove from our queue. Once our queue is empty, we just need to return this now. So we're going to have a return where we return our string, which is ret. I accidentally wrote string in there, that should be ret. So we're returning ret. So that is going to be what we return for our postfix expression. We've done this right here. This is exactly what we've coded. We're storing it in here, and then we're going to put it in here. Now we're going to work on our evaluate method, so we can evaluate the postfix expression and return an answer. After we do that, we're going to have our stack in our queue class. In Eclipse, it tries to help you out, and it's trying to help us out by putting this java.util, and what that does is it kind of puts the stack class in here. But we don't want that. We want to code our own stack. So if that happens, you just got to get rid of this. Again, that is so we can code our own stack in our own queue, because if we were to hover over it, we can import the stack and the queue classes that are pre-made, but we don't want that for this assignment. We have to make our own. So scrolling back down, we finished the infixToPostfix method for now, so I'm going to just minimize this, and now we have this evaluate. I'm also going to minimize the helper class for it, because we don't need these two anymore. If we were to hover over it, we can see it opens up, and we can look at the code, but we don't want that. These two are done for now, so we're going to look at just the evaluating method. I'm not sure why we're returning a string. We should be returning an int, and that is because our answer is going to be in type int, but we are taking the postfix expression as our parameter, so this is our parameter. And now what we're going to do is make a stack as a storage, and we are going to solve for this answer. The theory behind solving a postfix notation is also linked in the description below the like button. But basically what we're going to need to do is make a stack. We're going to put every operand, so it's kind of opposite of infixToPostfix, on the stack. So we're filling up our stack with operands. These are the numbers. And if we hit something that is an operator, so plus, minus, multiplication, or division, we are going to have to pull off two values from our stack, the top one and the one underneath it, and we're going to have to put them together with the operand in the middle. that's a rough kind of description of it. Again, the actual theory of that is in the notes linked below the like button. To make a stack, we're just going to have stack. We're going to need our angle brackets, specify what kind of integer, what kind of value we're passing in. We are passing in an integer, so it's going to be an integer, and I'll just call it storage because what it's really doing is it is storing our values. I'm going to set it equal to a new stack, and then the data type is also an integer. Since this will be a kind of method, we are going to have our parentheses, and that is how we made our stack. We'll get rid of this return, and we'll write the code that will actually return it. In our postfix expression, we're going to have to go through every single index. So to go through every index, just as we've done previously in our infixToPostfix, we are going to need a for loop. We're going to have for int a is equal to 0, and this is just like a temporary value. A is less than our postfix expression dot length. This will give us the length, and we're just going to have a plus plus, that way it'll increment through it. And now we are going to be in our for loop. So this is just going to be another for loop that we have to go through. We are going to again examine one character at a time. So we're going to have char, and we'll call this c is equal to postfix expression dot char at, and this is going to be at char a. And this is going to give us the character at the specific index of our postfix expression and store it in C. So if our character C is an operand, meaning it is a number, an integer, 0 to 9, we are going to be in an if statement. So we're going to say if, we're going to use the character class again, character dot is digit, and then we're going to pass in the current character, which is C. So if it is an operand, we are going to be in here. And then what we're going to want to do is push into our stack this value. So we're going to do storage dot push. We're going to use the push method, and then inside of here we're going to push in our digit. We can see that our storage is of type integer and our C is a type character. So we're going to have to change our character to be an integer. To do that, we are going to use the character class again, another character method in our character class. We're going to do character dot. If we do dot, we can see all of these different things that it comes up with. But what we're going to want to work with is specifically is get numeric value, and just typing in get comes up with these things. If we tap in this first one, we can see that we can pass a char in as a parameter. That's good. And it's going to return the int value that is specified with this. So if we double click it, we can see that C is already passed in, and we can end this right here. So we're going to push the character into our storage, and we can do this because we've converted our character to the numeric value if it is a digit. Now in postfix, we don't have any parentheses. That means that we don't need our else if statements to deal with them. So we're just going to have an else statement that handles all of the other operators. We're going to say else, and we need to run this as long as there are two things in here. So if there is just one thing left, well, we can't really add that. So we're just going to have to return. We'll deal with that in a second, but we have to make sure that there's at least two things in here. So that's easy. We can do it with an if statement. If storage dot size, so the size of our stack is greater than 1, we are going to add our values together. So we're going to be in our if statement, and we need to get the two values from our stack, the top two. The first one, the first top value, is going to be to the right of our operator. So I'm going to do int right for right, and I'm just going to set this equal to storage dot pop. So we pop the first value. And then we want to get the left one to the operator, or the one right underneath it. So we're going to do int left is equal to storage dot pop, and we're going to pop this next one as well. Make sure you spell it correctly and end it with a semicolon. And after we do that, we're just going to solve for this with our operand. Now we can do this all in here, but that's going to be a pretty big operation, and pretty big operations deserve their own method. So we're going to have another helper method, but for this case, for the evaluate method. And remember, because of the theory of postfix to evaluation, again linked below the like button, we are going to have to push this back to our stack. We're going to push the result of our operation back to the stack. So we're going to do storage dot push, and then we are going to have our method in here. We're going to have to write this method. So we'll call it solve since we are solving something. We're going to pass in three things. The first thing that we're going to pass is the operator. And remember, the operator is going to be this current C value. So we're going to pass in our left, we're going to pass in our operator, which is C, and then we're going to pass in the right value. After we do this, we can hover over solve and we can click create method. This will create a method right under here. That way we can code inside of it. So we can see that we take the left, we take the right, and we take our char. I'm going to change this to operator, that way we know what it is. It's not going to affect anything right here. It's just going to be what we call it for the specific method. That's just kind of the title of it. Because we're not actually manipulating itself, we're just pointing to it. So we get that value. I'm going to delete these two inside of here. Now what we're going to need to do is first off return an integer. So we're going to make a placeholder for that. Int, we'll call it result because it's going to be the result of the operation. We'll set it equal to 0. And now we have 4 different cases. We have addition, subtraction, multiplication, and division. So we're going to see what our operator is and then just use our left and right to solve for it. So if our operator is equal to a plus, and remember this is a char, so we're just going to have single quotes, and then we'll have a plus inside of it. If it is like this, we are just going to add our left and our right together. So we'll do left plus our right, and then we're going to have to store this in our result. So that is how we are going to do that. For the next ones, we are just going to use else if statements to solve for them. So we have else if, we're going to change this to a minus, and then we're going to change this to a minus. Else if, we're going to have another one, and then we're going to change this to a multiplication. And lastly, we'll have another else if. We could also just have an else statement, but again, I like to kind of be specific with what I'm doing. We'll have a division inside of here, and that will manipulate it to the furthest, and that will manipulate it depending on the operator. Now that we've done that, all we got to do here is return the result. So we're just going to return and then result. So once we return this, we are done with our helper method. I'm just going to have some commentary on top of it that describes what it does. This is what's going to solve our 2 operands and the operator with them. And that is in this else statement for the evaluate method. Once we've gone through our entire expression, we're going to end our for loop. So there's nothing left to do. We're just going to pop and return whatever is left in our stack. So we're going to do return and storage dot pop. And if we did our math correctly, everything should be combined, and that's easy to see again in the theory with this if we push it here and then manipulate it with this else statement, and so we're just popping the result. And that is going to be the evaluate method finished. We also have the solve helper method finished, so we can collapse this, and then we're going to collapse the evaluate because we are done with this. Checking in, we've finished our main method a long time ago. We've finished our postfix class, we've come to an end with it. And in our postfix class, we have this infixToPostfix, which will take our infix expression and convert it to a postfix expression. We have precedence, which is a helper for this. We have evaluate, which will give us the value of our postfix expression. And then we have solve, which is a helper method for evaluate. Now what we're going to want to do is make our stack and our queue classes. Before we do this though, we are going to need to make a node class because our stacks and our queues are both going to be linked list based. And now we can write below it. So we are going to make a class and we're going to call it node. We'll actually call it list node because it is a linked list. And for this kind of parameter, we are going to have this t right here. Now this t is not a string, it is not an integer, it is not a character. The t stands for generic type. That means we can pass in any value and have it be recognized and have it be valid, so we won't have any errors or exceptions. So we have class, list node, and then this t. Again, this t stands for generic type. So when we get the data stored in our first node, it's going to be of type t, again generic. We're going to have it as t data. This is basically setting it to a string or an int or a char or whatever have you, but we're just going to have t because it is generic. Of course, we have to have the link to the next node, and this is just basically going to be making a new list node. So we're going to have list node, and then of course the generic type t, and it's going to be called next because it is the next. After this, we are going to need a constructor for our nodes, and to make a constructor, we are going to have public and then our class name, so list node, and then we're going to have parentheses. We are going to be passing two values in here. We're going to be passing in our data, and we're going to be passing in our next. We have to say what type these are, so we have t data, and then we're going to have list node with the generic type t here for our next. And now we can be inside of our constructor. Inside of our constructor, we're going to do this dot data, so we get the very top data is equal to data. Again, the this is grabbing this data up here, the top one, and it's setting it equal to the data that's being passed in. Same thing for next, we're going to do this dot next, and it's equal to our next. So that is the constructor. And now we're just going to need getters and setters for our nodes. And those are the getter and setters, and that is the code for the list node class that we're going to be using. But we've made our list node class, we've done the postfix, we still haven't done the stack and the queue though. So we're going to do that now. We're first going to start off with our stack. We're going to start our class the same way. It's going to be class stack, and we're using a generic type because we've used the stack in two things. We've used it in our evaluate, and we've also used it in our infixToPostfix. Both of these are of two different types. So we have type character here, and then in the evaluate we have type integer. So we have to do the generic type for here too, as we've done with our list node, and we're going to do the same for our queue. Inside of our stack, because this is list node based, we are going to need to get our head, and we want to make it private so that we can't manipulate it in any bad way. We're going to do private list node, remember generic type, and this is the head. And we also want to keep track of the size of our stack because we do have a size method, so we're going to make a private int size. We're then going to have a constructor for our variables, so public stack parentheses. We don't have any parameters for this though, and then inside of here we're just going to set head equal to null because at the beginning we don't have anything in our stack, and then our size is going to be equal to 0, again because we don't have anything in our stack. The first and probably easiest thing that we should deal with is the isEmpty method. So we're just going to have a public, and it's a boolean because this is true or false, and it's called isEmpty. And then we're not passing in anything here, and all we're going to return is if the size is equal to 0. So we're going to return size is equal to 0. And if our size is equal to 0, it's going to return true. That means it is empty. If it is not equal to 0, it's going to return false, meaning it is not empty. Next thing that we're going to tackle is the peek method. So we're going to return the head of the stack without removing it. Well, we'll do public. We do want to return something, and it is going to be the head, so public type t. We're not passing anything in, but we will have a return, and we are going to be returning the head dot data. That is the value at the head. Next thing we have to do is pop. So for pop, we are going to take the top of our stack, or the front of our list in this case, and return it, but we're also going to remove it. So to do this, what I'm going to do is I'm going to make a temporary list that is equal to the head of our other list. Then what I'm going to do is set our list equal to the head of our temporary list plus 1 index. So not the head of the index anymore, but it's going to be equal to the next one plus everything after it. And then I'm just going to return the head. So that is how the stack would work, and that's how it would work with list nodes. So first we need to create our actual class. It's going to be public. It's going to be returning a data. We don't know what this type is, so it's type t, and it's called pop. We're not passing in anything. We're going to create a temporary node. We're just going to have it as list node temp t. We're going to call it temp, and we're setting it equal to the head. So this is going to be equal to the head of our list that is passed in. Now what we want to do is set our actual head equal to the next value in it, but not erase anything. That's why we need this temporary value, because if we break a link in a list, we lose everything after that. So we're going to set our head equal to head dot next, and that is basically saying our head is going to be the next value and everything after it, but we're going to get rid of the head. And after we do this, we're going to do size minus minus because we have subtracted 1 from the size. And then we are going to return temp.data. And this will return the first value in our temp, which is the head. And the head's cut off now. So we've done our public pop correctly. Now we're going to be pushing some value into our stack or into our list. So it's going to be a public void because all we're doing is pushing. It's going to be called push, and as a parameter we are taking type data. We don't know the type, again that's why it is a T, and then we have our brackets. So now we can write inside of our method. I accidentally put back here, looking over that, it should be the front of the list. So when we push data into the stack, we are putting it in the front of the list, just like in pop we are removing it from the front of the list. That's how stacks work. We are going to create our temporary list first. We are going to have list node. We don't know the type, so it is generic. We're going to call this temp and set it equal to new node. We don't know the type again. It is generic, so we're going to have that in there. And then we're going to pass in the data value, but we also have to pass in our null value. I also put node here. This should actually be a list node. And that is how we would create our temp list. So after we've created this temporary list, we only have the data value in it. We only have this single one value. And after we have this value, we need the rest of this list. So what we can do is say temp.next, because this is the next value after the head value of our temp. Because remember, the temp holds the data as the head value, and we need to get the next value that's not the head. So temp.next is equal to the head. And the head is the head and everything else following it of the actual list that we have so far. Once we have that stored in the temp, we can put this back into our head because the head has to have everything in it. This is just a temporary list. We can say that we are overwriting our previous list with our current order. So we are going to do head is equal to temp. Just like that, it is overwritten. After we do all this, we're going to have to do size plus plus. And now we have pushed successfully into our list. We are missing one method still, and that is the size method. We are going to have to return the size. So since we are returning something, it's going to be an integer. So we will have public int size. We are not passing anything as our parameters, and we're simply just going to return size. And that is the size method. And we have finished coding for the stack class. So that is what the entire class will look like. We have our private variables, we have our constructor, we have this is empty method, we have the peek method which returns without removing, we have the pop method which returns the stack with removing, that's super key, it returns and removes. We have push, which pushes the data to our stack, and lastly we have size, which will give us the actual size of our list. So that is the entire stack class. We've added it to the complete list with our list node and our postfix class, as well as our main driver class. Last thing that we have to do is make our queue class. So class queue, and then its generic type, because we're going to be passing multiple different things in here. We can do integers, characters, whatever, it's super generic. And the code for this is going to be similar for our stack because they are quite similar. However, they do have some key differences in the way they operate, which is why we have to code something new for it. First thing that we're going to want to do is make our private variables. We're going to have our private list node just as we did with our stack. Still generic type, and this is going to be our head. Unlike the stack where we're adding to the front, the queue adds to the back. So we are going to need to get the back of our queue. We're going to do a private. This will also still be a list node type generic, and then we're going to have back. Lastly, we need to do size, so we will have private int size. And just like previously, we are going to need a constructor for our variables. So we are going to have a public queue. Constructor is always the same name as the class. We are not passing anything as parameters. And then inside of here, we're going to set head equal to null because we have nothing in it. We are also going to set back equal to null because we also have nothing in it. And then size is equal to 0 because we don't have anything in it. The first thing that I'm going to do is make a add method, and this will add the data into our queue. We're going to be passed in some data. So we are going to have a void because we're not returning anything. It's going to be a public void, and we'll call it add.
we're passing in t data. And just as previously, whenever we add something, we're going to have size plus plus. We're going to want to make a temporary node to pass our data into, and then append that node to our list. So we're going to have list node. It's going to be of type t. We'll call it temp and set it equal to a new list node, type t. The values that we are passing in is data and also null. So that is our temporary null. And if our queue is empty, we're going to have to add it to the front. That's the only time where we're going to add to front. So we'll say if head is equal to null. And I'm also going to change this from back to tail, just to keep in the theme of linked list, because head is the front, tail is the back. So we're going to have if our head is equal to null, and also our tail is equal to null. That means our list is obviously empty. And then what I'm going to do is take our head and set it equal to the new list, which only has one thing in it, but that's okay, and it's temp. And then I'm also going to set the tail equal to temp as well. So that is if we have nothing in our queue. If our queue is not empty, we are going to be inner else statement, and we're going to do something similar to what we've done here. We are going to set our tail.next equal to the temp value, and then we're going to set our actual tail equal to the temp value. And that is how we would code the method for our and. Next, we need to see if our queue is empty or not. This is going to be a boolean, so we will have a public boolean. We're going to see if it is empty, so is empty, and we're not passing anything in here. We're just going to return if our size is equal to 0, and I explained why that is before. So the methods we have are add, constructor, and the is empty. Last thing that I'm going to do to really complete our class is to have a remove. And this is going to remove from the front of the list or the front kind of our queue. That's how queues work. So since we're removing something, we are going to have to return, because remove also returns kind of just like a pop, a type. So we will have a public generic type t, and it's called removed. We're not passing in anything, and then we are going to be inside of this method. If we remove something, we're going to have a size minus minus. And just as we did with the pop, we are going to manipulate the head of our list, or front of the queue. So we want to store the current front, because we are going to be returning it, and then since we are removing it, we are going to set the front equal to the next value. So we need to make a generic type. This could be string, int, character, whatever, and we're going to call it temp. We're then going to set it equal to head.data. This is going to give us the head of our list and store it in the front. After we have this set, what we're going to want to do is set our head equal to the next value, because we've removed the front value. So head is equal to head.next. And then all we're going to want to do is return the temp, which is holding the head. And that is it for this method. And we can close off our class because our queue class is now complete. So with all of these complete, it is time to test this. If I go into the console, I'm just going to copy this, run it. It says to give me an expression. We're going to paste this in, and it looks like our postfix is correct. However, our answer is not. So we're going to go and troubleshoot the code. We're going to be in our postfix class, because that's where our evaluation is. It looks like there is something wrong with our evaluation. Our evaluation method is right here, and so is the solve helper. Looking at this, I can see something already wrong, and it's in the solve helper class, and it is in the solve helper method. The error here is that we have a plus for this plus, we have a minus for this minus, we have a multiplication, but we have a minus for it. So it looks like we are not doing our math right. If I put a multiplication here for multiplication and then check division, that is good. We can save this and run it again, and then we are going to try to give it an expression once again. If I paste this in, it will give us 6 as our answer. If I try to run a different postfix, like let's say this, it's going to give me 29, and that is the correct answer. So it looks like we have our code completed. We've labeled everything. Everything looks good, so that if we were to come back to this in the future, we know exactly what everything does. And that's how you would go about coding for all of these classes and for this entire assignment.